Okay, welcome to part 2 of this video. So what we want to do in order to figure out how to get the real solutions out of that one complex solution is we're going to do just a tiny bit of theory here. We're going to assume that y, which can be broken up into a real part, which I'm going to call f, plus I times g, where f and g are both real functions. Let's assume that that solves the differential equation that we've been trying to solve this whole time, right? This second order linear homogeneous equation with constant coefficients. Well, if it solves this equation, and y can be written as f plus ig, let's plug in f plus ig into this formula and see what we come out with. All right, so y double prime, this is going to be f double prime plus I g double prime, plus p times y prime, that's going to be p f prime plus I p g prime, and plus the last term here is going to be qf plus I q g. Right, and that should add up to 0. Now, the thing we want to do here is we want to isolate, or rather group together, all of these imaginary parts. And similarly, we're going to group together all the real parts. And so what we're going to have is that f double prime plus pf prime plus qf, those are all the real parts gathered together, plus I times the entirety of g double prime plus pg prime plus qg, that has to add up to 0, right? So the real parts right here, the imaginary parts right here, their sum has to add up to 0. And if you think about it, the only way that a complex number can be equal to 0, and this is really, we have a complex number here. We've got all of this f double prime plus pf prime plus qf stuff. That's the real part of our complex number. The imaginary part is all of this I g double prime plus pg prime and so on. That's the imaginary part. And the only way that a complex number can be 0 is if both its real part, so the stuff with the f's, and its imaginary parts are 0. Right? That's the only way that you can have a 0, a complex number be equal to 0. And so if we write down what this means explicitly, well, let me just get some space here. If we write down what this means, we need the real part to be equal to 0. So f double prime plus pf prime plus gf must be equal to 0. Right? This is what we get. And so what that means, if you think about it, is that f must also satisfy the differential equation that y solved. Right? This differential equation right here is exactly the same as the one that f solved right above it. Right? They are identical. The only thing that's changed is that up here I say f and down here I say y. And so what that means, right, if you want some jargon to take away from this, is that if you have a complex solution to a differential equation, both its real parts and its imaginary parts will solve that same differential equation. To see that the imaginary parts do, come back down here and just rewrite exactly what I wrote with f, but with g. All right? And this is what's going to let us pick the 2 real solutions out of that one complex solution we found in the last video.